Hello students, today we are going to start the redox reaction. Okay. So in this series we will try to understand the meaning of redox reaction, types of redox reaction, oxidation number, reducing agent, oxidizing agent, competitive electron transfer reactions. This all we will try to understand. So dear student, if you see this term is there red and that is OX. So RED means what student? Reduction. Okay, reduction, and OX means oxidation. So dear students, how can you try to understand the reduction and oxidation? So any reaction, any reaction in which the oxidation and reduction both are taking place together simultaneously is known as redox reaction. Any reaction in which oxidation as well as reduction reaction are taking place together are known as redox reaction. Now we know about the burning of fuel. Okay, decolorization of cloths or other material using bleaching agent, rusting of iron, and production of current from the galvanic cell. These are all the chemical process involving the transfer of electron and named as redox reaction. Okay, so dear student, you can try to understand that is burning of fuel is also the redox reaction. Decolorization of clothes, that is redox reaction. Other material using bleaching agent, redox reaction. Rusting of iron, redox reaction. Production of current from galvanic cell is the redox reaction. So all these are the redox reaction. Redox reaction are comprised by oxidation and reduction process. Okay, so definition of redox reaction, you see student, in the term redox reaction, red stand for the reduction, red stand for reduction, and OX stand for oxidation. Oxidation and reduction can be defined by the three common concepts given. Early or old ideas of oxidation and reduction, that is electronic concept and oxidation number concept. First one is their electronic concept and second one is oxidation number concept. So if you talk about the early and old ideas of the redox reaction, that is oxidation number. Okay, so we are going for the old and then we will go for the electronic concept. So addition of oxygen or any other electronegative element, or removal of hydrogen or any other electropositive element is called oxidation number. So for example, magnesium added to oxygen, MgO, so this is oxidation. Sulfur added to oxygen, that is oxidation. Methane added to oxygen, that is oxidation. Hydrogen sulfide added to oxygen, that is oxidation. Magnesium added to electronegative atom fluoride, that is MgF, to oxidation. And if you talk about the, okay, this reaction student, 2K4FeCN6 added to H2O2, so it is giving 2K3FeCN6 plus KOH. So addition of H2O2 also is the type of redox reaction. Here they are saying equation 1, 2, combination of oxygen has occurred. In equation 3rd and 4th, displacement of hydrogen has occurred. In equation 5th, the combination of the electronegative atom F2 occurred, while in equation 6th, displacement of electronegative atom K has occurred. So this is the what is the old concept of the oxidation reaction student. Now if you talk about the reduction, the removal of oxygen or any other electronegative element from a substance, or addition of hydrogen or electropositive element to a substance is called reduction. Okay, what they are saying, the removal of oxygen or any other electronegative element from a substance, or addition of hydrogen or electropositive element to a substance is called reduction. For example, HgO is there, it is giving 2Hg plus O2, right? Next one, FeCl3 plus H2 is there, FeCl2 plus HCl. Okay, CH2, here also addition of hydrogen is there, here HgCl2, SnCl2. So HgCl2 plus SnCl4. So here if you talk about equation 1, removal of oxygen, from mercuric oxide. In equation 2, removal of electronegative element chlorine has occurred from ferric chloride. In third, the addition of H2 has occurred, and equation 4th, the addition of electropositive Hg plus has occurred. Okay, now redox reaction in term of electron transfer, that is electronic concept. Okay, redox reaction in term of electron transfer. Okay, so electronic concept we are going, that is also known as the modern concept, right student? Modern concept. So how can you understand the modern concept, dear student? Let us try to understand. The loss of electron by any species is called oxidation. So 2Na plus S is Na2S. In this equation, each Na has lost one electron. So that is Na has lost the electron and sulfur gain the electron. So that is loss of electron has taken place. So that is the oxidation. If we talk about reduction, gain of electron by any species is called reduction. In general reaction, S undergoes reduction. So if you talk about S has taken 2 electron, so it forms S2 minus. So this is reduction. In above reaction, Na is reducing agent, and while oxygen sulfur is oxidizing agent. Oxidizing agent, electron acceptor is called oxidizing agent. Reducing agent, electron donors are called reducing agent. In general, the species that undergoes oxidation is reducing agent, and the species that undergoes reduction is called the oxidizing agent. Competitive electron transfer reaction, student. Let us try to understand meaning of competitive electron transfer. When we place a strip of metallic zinc in an aqueous solution of copper nitrate for about an hour, it is noticed that the metal strip becomes coated with the reddish metallic copper and the blue color of the solution disappears. The reaction between metallic zinc and the aqueous solution of copper nitrate is what is happening? Loss of 2 electron, copper nitrate, loss of 2 electron from zinc and gain of 2 electron by copper 2 plus. So here you can see the reaction. Zinc is losing 2 electron, Zn2 plus, copper 2 plus electron is getting, so copper solid. But the above reaction is reversible. Reverse direction is not practically seen. Similar case is seen in the given example. Copper 2 plus, Ag plus, it is giving silver. Okay. So copper releases 2 electron to go copper 2 plus, and silver no gain 2 electron, so it is going Ag. So the solution thus develop blue color due to the formation of Cu2 plus ion in above example. In contrast, consider the reaction of metallic cobalt placed in NiSO4 nickel sulfate solution. So cobalt plus Ni2 plus, it is giving Cu2 plus Ni. So at equilibrium, chemical test reveals that both Ni and Co plus are present in the moderate concentration. In this case, neither the reactant, that is Co, and Ni are greatly favored. The competition for the release of electrons can also be explained from electrochemical series. Okay, so here their zinc rod is zinc rod placed in the copper nitrate solution. Intensity of blue color is released, you know, intermediate state, and finally final stage, copper deposited on zinc. Finally copper is deposited on zinc and color of the solution become colorless. Now copper rod dipped in silver nitrate solution, blue color start. Okay, intermediate, intensity of blue color increases, final stage, silver deposited on the rod. So this is the redox reaction between copper and aqueous solution of silver nitrate occurring in the beaker. Now the next point is there, student, that is rules for oxidation number. In uncombined state or in free state, oxidation number of element is 0. In combined state, oxidation number of fluorine is -1, oxygen is -2, in peroxide -1, in superoxide minus 1 by 2. However, in F2O it is the +2. Okay, hydrogen is +1, in ionic hydride it is -1, that is group 1, 2 and 13. So this is the hydrogen is +1, in ionic hydride it is -1, group 1, 2, 13. 1, 2 and 13, that is -1. Halogen, it is -1. Halogen as halide, it is -1. Sulfur as sulfide, -2. Metal has positive oxidation number almost all cases. Alkali metal +1. Alkaline earth metal +2. Algebraic sum of the oxidation number of all the atoms in a compound is equal to 0. KMNO4 they have taken example. So they are taking, that is oxidation number of K plus oxidation number of Mn plus oxidation number of O into 4 equal to 0. So plus 1 plus 4 into minus 2, that is 0. The algebraic sum of all the oxidation number of element in radical is equal to the net charge on the radical, that is CO3 2 minus. So oxidation number of C plus 3 into oxidation number of O equal to minus 2 into plus 4 plus 3 into minus 2 equal to minus 2. So oxidation number can be 0, that is positive, no, negative or integer or fraction. Maximum oxidation number of an element is valence electron in general. Minimum oxidation number of an element is valence electron, that is -8, not valid for the metal. So element compound highest oxidation number. So NaCl, that is plus 1, MgSO4 plus 2, AlF3 plus 3, SiCl4 plus 4, P4O10 plus 5, SF6, that is plus 6, ClSClO4, that is plus 7. Some common calculations of the oxidation number of underlying atom. Note, let us A is the oxidation number of underlying atom in each case. So if you talk about HNO3, so N is the, we have considered A, hydrogen plus 1 and oxygen minus 2 multiply by 3, so it is coming, that is plus 5. HSO3 minus, it is coming plus 4. Okay. If you talk KO2, see, this is the superoxide, so that is, it is coming, that is potassium is plus 1, 2 into A, that is 0, so A is equal to minus 1 by 2. KMNO4, it is coming plus 7. It is coming, if you talk about the, this complex is K3CuCN4, that is plus 1. So like that you will be able to calculate the oxidation number. Here H2SO5, they are saying the oxidation number of sulfur can be more than the 6. The wrong value plus 8 is due to the reason that the 2 of 5 oxygen atom are linked by peroxide linkage and thus minus 1 oxidation number. So here you can see that this one. So dear student, this is all about the oxidation number. Oxidation number of some other compound from structure. Sometimes we come across with certain compounds in which the oxidation number of a particular element in the compound is fraction. For example, C3O2, where oxidation number of carbon is 4 by 3. Br3O8, where oxidation number of bromine is 16 by 3. And Na2SO4O6, where the oxidation number of sulfur is 2.5. The fractional oxidation state is the average oxidation state of the element under examination, and the structural parameter reveal that the element for which fractional oxidation state is realized is present in the different oxidation state. Structure of the species C3O2, Br3O8 and S4O6 2 minus reveal the following bonding structure. So oxidation number of each: Br in Br3O8 plus 6 and plus 4. So oxidation number of each carbon in carbon suboxide is plus 2. Structure of C3O2 carbon suboxide is like that. Okay, this is the, now the oxidation number of each sulfur ion tetrathionate is plus 5 and 0. So that we have to check out the super peroxide linkage also. Sometime oxidation number have such value which is first site appears stages. For the example, the oxidation number of carbon in cane sugar, glucose and dichloromethane is 0. Cane sugar, glucose, if you calculate, this is coming 0. Okay, so this is all about the introduction of oxidation number, student. Thank you so much for watching.